Good morning. I've been coming to CDIO for about 4 years, and I work at the Schulich School of Engineering at the University of Calgary in Canada. And I used to teach in art, so I have an art background, and since about a year I'm tenured in mechanical engineering. Big surprise still to me, but anyways, I'm sticking with it. So I teach kind of the softer side of engineering design courses, lots of drawing, technical writing, oral presentations. My portfolio is expanding every year. And one of the workshops that I've done at CDIO is the engineering reasoning workshop, and I'm assuming that a lot of you have done this workshop. Can I see some hands? People that have done engineering reasoning? Yeah? No? Not that many. Okay. So I highly recommend it. Rob, are you going to do it again this week?
Part of it this afternoon.
Okay, yeah. So you need to look for Rob, and you need to take this workshop. It's very, very good. So I started to use it right away after the first time that I took the workshop in my courses, and I also teach, besides the design course, a technology and society course, and it's very useful in that course also. So in the first or second week, I have the students do more or less the format that Rob presents at this conference. So they get the executive summary from the Columbia disaster, they get the list of questions that is associated with engineering reasoning, they go through the exercise, and for me it's a way to say this is what actually needs to be in your document. So when you're creating a document for me, I also need to be able to ask those questions of your document. And here's my overview. So I'll talk about, I'll show the little booklet that you can buy as well, which I make my students do. I'll talk a little bit about BOP design if you don't know what that is, and then the visualization and the engineering reasoning exercise that I have the students do, and a few results. Just up front, a little sample design process, which I found a nice representation on the internet the other day. So from agony to fun. So the concept stage is really not that much fun, and we don't focus enough on that phase, right? A lot of things we do with our students is all about fun, which is implement, operate, usually. But the concept stage is very difficult, very painful, usually. So the tools I'm using for this project, like engineering reasoning and these visualization exercises, are to make the concept stage less agonizing, I guess. This is having an idea that works, right? That's kind of, here we go. If you actually have a little business, then you might get some joy out of writing an invoice, but other than that, the actual doing of the design is tension-based, right? Because you have a deadline and all this kind of stuff. So some possible help during the concept stage. So this is the engineering reasoning booklet. And it's very thin, it's very affordable, and the students paid $7 in Canada, so that's not too bad. And it introduces some two elements that need to be in an engineering document, and it frames it in engineering language, which was so helpful for me, because I come out of an art background, and if I start to talk about social case studies or things like that, they kind of go, oh, not social sciences again, that's why we left high school, that's why I went to engineering, we don't want to discuss it. But with this booklet, I can make everything into engineering, which is fantastic. Right? So everything becomes engineering, which is perfect because I can speak about any document using engineering language that makes sense to them. So this is what the workshop looks like, more or less. So I don't know if you still do the same. Is that?
Yeah, it won't be this afternoon. I'll give copies of that booklet away this afternoon.
Okay. I found this very useful. This is an executive summary of one of the spatial disasters and what went wrong with NASA and all this kind of stuff. And then a list of things that the students need to be able to pull out. So what was the main point of the document? What were the assumptions? Right? What are the main questions in the document? So they start to pull out all this nice information. So for the project, we worked with Engineers Without Borders for a 7-week project, and we have 700 students in this class. They work in groups of 4, so that's a lot of teams. And this project was looking at case studies in African countries and trying to come up with solutions and very much looking at how to involve or how to co-design basically these solutions, right? Looking at local materials, local customs, trying to keep it sort of, well, real world as much as possible. So BOP design is based on the pyramid design. It's, you know, kind of a new area in the design world. Basically, today I think 90% of engineers work and design for 10% of the world's population. So there's a huge percentage of the globe that does not have access to engineering knowledge or engineering expertise. And I'm trying to tell the students that this is really an up-and-coming area. To put a figure to it, right, it's a $5 trillion area. And this is not about, you know, trying to get the $2 a day that those people make. This is coming up with good products, right, that are inexpensive, that are innovative, and that are necessary for those communities. So that's what the project is about. I also tie this to the 2015 Millennium Development Goals from the UN. Well, these goals are already not on track, but these are the sort of areas that the UN has zoomed in on to sort of work in these areas to create improvements. And I think engineers have a huge role in all these areas, right? And again, if we think about, you know, 90% of engineers working for 10% of the population, right? Lots of engineers should start focusing on these areas and other parts of the world. So the students had two tasks when they got their case study. They had to visualize connections between areas that were in the case study. So that was things like health, water, transportation, housing. So they had to find connections, and are there related areas, right? Is one area influencing problems in another? And then they also analyzed the engineering, or Engineers Without Borders profile using engineering reasoning. So for the visualization, I used a website that's called the Periodic Table of Visualization Methods. And it's an e-learning site, and basically it shows students, you know, different ways of visualizing information, which I find is a hugely important skill for students. So an Excel graph is not always enough, a pie chart is not always enough. Sometimes data is more complex and has to be represented carefully. So this is what the site looks like, and in the paper there's a link to it if you're interested. It's a little crude, and at first I thought I'll never use it, but the nice thing about this is if you hover over any of the little squares, you get an example pop-up of what that looks like, and then you can do further research into other websites and find out more about that particular visualization method. But it's nice and concise. One page, you hover over things and you think, okay, I have this kind of information, I should be able to put it together using this particular graph. Okay. So some examples. So this is from one group, the next four images. So this was the information that they pulled out in terms of, here you can see the categories, so energy, agriculture, health, shelter, transportation, education, and water. This was a different kind of visualization, so each team had to use a different visualization style, and hopefully you start to either find patterns or you start to have one thing that keeps coming up over and over, and then they were asked to zoom their design into that particular area. This was a very beautiful one, I must say. It's always great as a teacher to get these students that will spend 15 hours on assignment, which they complain about, but then frame it and send it to grandma. But this one was very beautiful, and this girl had not drawn before she came to the course, which is astonishing. You should see her other stuff, and anyways, I'm keeping an eye on her. But this was that other one, the Sankey diagram. So these four were all the same document, but different styles of visualizations, and hopefully information was coming out of that that they could use for their project. Here's another one. This is called a knowledge map. So you can see here the kingdom of agriculture, the dominion of water, education, utopia. This is a style of visualizing information components, and then the related areas are indicated by arrows and connection lines. Here's another one. So in terms of importance, right, and sort of it gets smaller as we go out of these, this is a cycle diagram. Here's another kind of visualization, more graph-based. I mean, the image in the back is nice, but not entirely necessary. So engineering reasoning was used again, as I said, for the case studies. And I've been running Engineers Without Borders projects for probably 5 or 6 years. And the previous years, students had always immediately said, oh, how do we know what the problems are abroad, and we don't want to deal with this, and we don't want to read about this. This is social, right? In Calgary, they say it's social sciences. We don't want to work on this. The nice thing about this was that they could use the language used in the booklet. So engineering reasoning, they immediately started to pull elements out of the document. They were much better at getting the main points out of it, seeing if the document was biased in any way. And engineering students are generally very good at getting the information out, right? If they are given the right set of questions. So all these student sort of comments and write-ups are in the paper. It's not very interesting to see tons of text, but here are just a few sort of points of view taken out of the case study. Important information, the key question. What's the key question of the document, and is that going to help them with their design project? The main purpose, so the full text is in the paper, so it's not too interesting to look at that. So then the results, right? Students have, as this is now becoming more popular, this term, I don't know how to pronounce it, but they're big, hairy, audacious, worthy goals, right? Students are always coming up with fantastic things, which is why it's so great to do these projects with them. We had an open house, which is common after design projects, so we had 175 projects on display, and they had to do a prototype, they had to do a poster, they had to do a brochure. So I mean, the project was much larger than the engineering reasoning and the visualization. But what was interesting to me is that the visualization started to appear in the posters, which was my big hope. The terminology from the engineering booklet started to appear in the posters as well. So they were starting to talk about our assumptions in our projects and our main question that we tried to answer. And that was really nice that they translated what they'd learned from the engineering reasoning exercise into the presentation material, and they were sounding more professional than in the past. So here's an example of one of the visualization diagrams in one of the brochures. These guys had a cooling fridge. The ideas were very interesting, so they'd really done lots of research. They looked at sustainability. These guys are putting on a show. Here, lots of sort of information graphics. These guys have done a very low-cost projector for teaching purposes. And then here you can see, the headings started to pick up the headings that were used from engineering reasoning, so assumptions. And lots of sort of nice prototypes. These girls had cast 2 big chunks of concrete for this grinder. And people had grown food, so rotating crops and things like that. Lots of solar type activity, again, companion crops and sustainable agriculture. And then this was my great joy when I saw this engineering article, which I'd never seen with a social project, right? So they actually started to see the case studies that they were getting from Engineers Without Borders as an engineering article, which was for me like the big jump that they made, is that they didn't say, this is not engineering, this is social, we don't want to deal with this. They actually said, okay, this is an engineering article, we have to pull out the information, and then we're going to use that to do our design project. So, as the conclusion says, in previous years, students were reluctant to look at these things. The students using engineering reasoning started to take it serious right away, and it helped them with their writing, right? It helped them with their final report, because they started to include all these elements, right, that make up a good executive summary, that make up a good sort of introduction. and assumptions and outcomes. So that is what I have for you. Thank you very much.
Marianne.
Yeah.
We have time for some questions.
So for you, do your students actually like go to Ghana to learn this, or they just read the report and then they come out with a project?
They have to do. We can't go with 700 students to Ghana. I would like to do that, but that's. So they do most of their research on the internet, but we do have a lot of Engineers Without Borders students who have experience abroad that are there as consultants during lab time, right? So in their concept development stage, we do have a lot of people who have that experience that walk through the labs and answer questions while the students are trying to digest the information.
Many of these students come from civil engineering departments.
No, the reason I ask is that we also do some of that, but I guess maybe for us in Singapore, there are quite a number of developing countries, so we send our students out. The sense of confidence and the sense of achievement is a lot more. When the students go there, they empathize with the villagers, and then they work out something that the villagers can appreciate. This one, the sense that I have is you're doing design in isolation to some extent.
You're absolutely right, and to bring it closer to home, we did that same year do a project with the Calgary sort of homeless population, and that was closer to home, and that was, as you said, that's a much more impactful kind of activity, right? We had lots of guests that were telling the students about how their life had gone from here to here, and they really took that on to try and make that person's life much better, right? So I realized that these are removed projects, but it is good for them to have a look at situations where not everything is available, right? Calgary is one of the richest places in the world at the moment. Also one of the most evil I saw on TV last night. But, I was watching an oil movie, and Calgary was shown full of cowboys, and nobody cared about the environment, so which is partially true, but anyways, I won't go into that. But it's good for them to have to place themselves into somebody else's shoes, even if it is somewhat remote. I realize that that's not ideal, but they have to start thinking about these kinds of problems, right? And they're not going to go away, and that engineering solutions are going to make the difference. Any other
questions?
questions?
No. Thank you very much, Maria.
Okay, yeah.